Now, I would like you to turn to page 192. And I think on page 192, you have a completely blank page, right? Sometimes I will add another example that I think would help you to your notes, and then I'll refer you to one of these extra pages to do that, okay? Almost all the textbook questions have been dealing with function notation questions, so I want to give you another example with an explicit equation using the colored pages that we started. So I'm going to get you to graph y equals 3 bracket negative 1/2 x cubed. So the difference from this and the textbook examples always gave you a picture of the original graph. These ones don't. So the first thing you have to do is recognize which parent graph we're dealing with. Here, this is an x cubed graph. From our colored ones, that's the one that swoops like that. That was on the yellow page. So off to the side, I know its shape. I know 3 key points were 0, 0, 1, 1, and negative 1, negative 1. And this is why I mentioned having those original graphs memorized and knowing their shapes was important. Okay? Now we can go through the same steps that we went through when we were doing our other examples. What were those same steps? Well, I would probably label, is that 3 inside or outside the function? Outside. Vertical stretch, you're going to multiply your y values by 3. The negative, inside? Yes. Horizontal reflection, the half, inside? Yes. Horizontal stretch, these together, you're going to multiply your x values by a negative 2. What does our algebra look like? Well, we're going to take 1, 1, 0, 0, and negative 1, negative 1. We're going to multiply our y values by 3 and our x values by negative 2. Negative 2, 3, 0, 0, and positive 2, negative 3. You're also going to see me more and more saying, if you've got one graph here, when you go to graph your second graph, put it on a new graph, because otherwise things get busy. It's hard to label. It's harder for you to see what was happening. So I'm going to start a new graph. I'm going to label negative 2, 3, 0, 0, and 2, negative 3. I'm going to make those blue because I changed to blue. So I labeled the points and I drew my new graph. Okay? What I did here, I also included a very typical mistake that in the grade 12 pre-calculus, the province used to say, every time a student makes this kind of mistake, you have to take off a half a mark. The mistake that I made was I didn't label things. It seems obvious that these are going up by 1. But someone might say, maybe you're going up by 10s. Even though it seems very obvious, just to make sure, if we label those points, now the scale of our graph is given. So if you draw a graph and don't provide a scale, it's always a half a mark deduction. So again, it's just paying attention to details. This course is very fussy about details, and I'll teach you all the details that they're fussy about as we go. This is one of them. Also, arrowheads, another fussy detail. You forget arrowheads, it's always a half-mark deduction. The province picked 10 of these, and they actually labeled them error 1, error 2, error 3. So one of the things I do on quizzes is I still label them according to the province's original error labels. Not labeling your graph was an E9. Forgetting arrowheads is also an E9. They're both with graphing, so they were both considered E9 errors. Question? Outside. It's not really, so what you want to be able to see, to develop your brain to see, is if the original question was x cubed. For this question, inside is where the x is, anything that's getting cubed. So when I go over here, is this 3 getting cubed? No. Outside. Is the negative getting cubed? Yes. Inside. Is the half getting cubed? Yes. Inside. So anything that the original function, like if you have a square root, if the stuff is getting square rooted, we call that inside. But there's not really a cheat sheet or a thing to write it down. It's just practice being able to observe which one is which. Inside is always horizontal. Outside is always vertical. Vertical always affects the y coordinates. Horizontal always affects the x coordinates. If something is where the x originally was. So sometimes students go, I'm going to put the x in brackets so I can see anything that would get cubed in the next part I'm going to say is inside. Okay.